Hi guys, this my name is Harsimran, and I have started with my YouTube channel from today onwards, and I'm very excited to share the name of my channel as Code with Harsimran. I've graduated in computer science and engineering from Thapar Institute of Engineering and Technology, and I'm currently working as SD1 at Optum UHG. So, today I'm going to start with the new playlist which comprises of top 150 interview problems, which is a study plan on lead code. So let's get started with the first problem of this study plan, that is merge sorted arrays. So typically in this problem we are given two integer arrays nums1 and nums2 sorted in non-decreasing order, and two integers m and n representing number of elements in nums1 and nums2 respectively. So what we are actually given over here is we are required sorry we are given two arrays nums1 and nums2. And two integers m and n respectively. So we are required to merge these two sorted arrays into a single array in increasing order. So, and the further question states that the final sorted array should not be returned by function, which we can see that the given function is of the type void, but instead it should be stored inside the array nums1. So we can see that we have to return a final result in nums1 vector. To accommodate this, nums1 has a length of n plus n, which is implicitly given, where first m elements denotes that which are to be merged, and the last n elements are set to 0 in this vector. And nums2 has a length of n. So let's take the test case 1 for this. We are given nums1 and nums1, and m is equal to 3, 2, 5 and 6. That's what we are given, and we have to return the final output as 1, 2, 2, 3, 5 and 6. That's what our final output is. So let's discuss how to approach this problem when we are given this problem in an interview. So first of all, what we are required to discuss with the interviewer is the brute force approach, the better approach at second, and the third one is the optimal approach. If we move in our interview towards a problem in this fashion, it will give a clear insight to an interviewer, a clear insight to the interviewer that we know the possible solutions that could occur, and also it gives him or her an insight that we have not crammed the solution. So this is what the technique in an interview is. So so before moving in an interview, we are required to discuss the constraints, as we are already given in the question that nums1 has a length of m plus n and nums2 has a length of n. So we are very much clear after seeing the first two constraints that the elements that are present in nums2 can be easily accommodated in nums1, where the elements where they are set to 0, 0. So we can simply say that 2, 5, 6 can be easily accommodated at this place, right? And this is the size of the array that it is it is between 0 to 200, and the maximum length of the nums1 could be 1 till 200, and the numbers are in the integer range, that is minus 10 is to the power 9 to 10 is to the power 9. That's what we can say. So the follow-up question with this is that can you come up with an algorithm that runs in O of m plus n time? So I think the follow-up has given us a way to approach this question in the better in the optimal direction, right? So we have got a hint from this problem only. So let's get started with the discussion. So after seeing this problem at first instance, forget about everything, the brute force, the better and optimal one. So suppose you are given this problem, like if I say in the desi language that तुमको रात को 2 बजे क्या कहते हैं, कोई तुम्हें क्या कहते हैं उठा के पूछता है कि what you will do in this problem. So brute force is what I describe in my language as the solution, कि आपको रात को 2 बजे आप नींद में हो, आपको किसी ने उठा के कहा कि भैया ये क्वेश्चन, कि भाई साहब ये क्वेश्चन सॉल्व करो. So what you will do? You will see that you are given 2 sorted arrays, and what you will simply do, you already know the fact that there is the space of size n which is empty, and we can easily accommodate these elements which are present in nums2 in this space. Let me do it below. So nums1 1 2 3 0 0 0 m equal 3. nums2 is 2 5 and 6. So we all know that we can simply use an STL function, which is sort function. So what we will do, simply we will copy all these elements in nums1. So the resultant nums1 would be 1 2 3 2 5 6, and then run the sort function, and we will get our resultant array as 1 1 2 2 3 5 6. So the time complexity of this solution is n log n, since we are using the inbuilt sort function, and the space complexity is O of 1, since we are not taking up any extra space. But interviewer will not be happy with this approach because we are having a greater time complexity. So we need to cut down our time complexity. So let's move on to the better solution of this problem, the better one. So first of all, let's just draw both of these arrays. One, two, three, 0 0 0. nums2 is 2 5 6, m equal to 3, n equal to 3. First, after drawing, we can see that both of the arrays are sorted as given in the question in increasing order, and we know how to merge two sorted arrays, right? And this knowledge we have from the merge sort algorithms, and I think this technique we have learnt already in the merge sort algorithm, where we are using a merge function to merge two arrays. So we can simply apply that merge function on nums1 and nums2, and I think we are very good with it. So let's take two pointers I and j and merge nums1 and nums2 in some temporary array, and the size of this temporary array will be m plus n. let's take a pointer k. 1 2 3 4 5 6. Okay, let's take a pointer k initialized to 0. So we will start comparing both the elements. Since nums1 of I is less than nums2 of j, we will simply insert it in the temporary array, increment our I pointer, and j remains as it is. Now we will compare I and the elements at nums1 of I and nums2 of j. Since both of them are equal, we can take either of them. I will take the first one. I'll insert 2, increment k, and increment our I pointer. So 3 is greater than 2. So we will insert 2 in our array, increment k, and increment our j pointer, and I will remain as it is. So comparing 3 and 5, 3 is less. Insert 3, increment k, and I think I has reached equal m. So we will come out from a while loop. And then since we know that this is a sorted version, we will simply insert these elements as it is in our array. And I think we are done with the answer. We have got our answer as temporary. But as given in the question, we have to, but as we are already told in the question, we have to return our output in nums1 array. We will simply copy this temp to nums1, and our solution is done. So the time complexity involved in this solution is O of m plus n, since we are traversing on both nums1 and nums2. And the space complexity, since we are using a temporary array of size m plus n, comes out to be O of m plus n. And we are done with the solution. Interviewer will be a little bit happy, like his smile, which was the face which was position at brute force, position at better, and the position at optimal solution. We have reached this with this the solution where he is neither happy nor he is sad. He would be a little bit sad because we are using a time complexity of O of m plus space complexity of O of m plus n. So in order to make the guy happy, we have to optimize our space complexity optimization. So let's just move to the optimal solution. Let me draw the array first. So we all know that this empty space can accommodate all of these elements, and since we are required, I'm sorry, I misplaced it on wrong pointers. I have to draw it over here. And since we are required to give our final output in increasing order, so why not start with the last element, the merge function which we are using from the initial part. Let's just start it from the end so that we can effectively use this extra space of size n which is present over here, in order to accommodate all of our elements. And as we know that our elements in nums1 and nums2 are in increasing order, so even if we complete up with this, so even if we complete this array, traversal on this array is completed, we are not required to move any further backwards, and we will get a sorted array at once. So let's get started with this dry run. So we will compare both of these elements, and the one which is greater we will insert it at the end, at the kth position, which is the last position of this array, m plus n minus 1. And subsequently we will decrease our k pointer and insert it at the kth position. So amongst 3 and 6, the element which is greater is 6. We will replace it with 6. Let me take a good color. And replace with 6. Decrement our pointer with j and decrement our k, since we have already filled this space. So comparing 3 and 5 is greater than 3. We will replace this element with 5, decrement our k and decrement our j. Since 3 is greater than 2, so we will replace this element with 3, decrement our I and decrement our k. Since 2 and 2 are equal, I will prefer taking this 2, replace it with the element present at kth index and decrement our k, decrement our I, and continue. Since 2 is greater than 1, I will simply place my element at k. I'll simply place 2 at kth position, and j has reached to minus 1 over here. So in this way we have sorted out only 5 elements, but one is already at its correct place. So we are not required to do any comparisons over here, and we can simply return our answer as 1, 2, 2, 3, 5, 6. With minimalistic comparisons, we are done with our code. The time complexity involved over here is O of m plus n, as we are traversing on both these arrays, and space complexity turns out to be O of 1, as we are implicitly placing our elements in nums1. So let's get started with the code of the same. So let's get started with the code. Take a point. What is happened now? Of I is greater than nums2 of j. I will simply place it at nums1 of k, my nums1 of I, and then I'll decrement my I, else I have to place my nums1 of k with nums2 of j, and I'll decrement my j, and in every case we are required decrement k and involve in whatever. Let's just run the code. It has a code. Okay, so we are required to handle another edge case while j is greater than equal to 0. Since our m, oh, I have got it. Since we are already given in this constraint that m could be 0, so we are required to handle this case that if our n is, and our n could never, if our n is greater than or equal to 0, we will simply place nums1 of k with nums2 of j minus minus a minus minus. Just run the code. Yeah, and it's working fine. Let's submit our code. So I think you can see, don't believe in the time complexity of the lead code, but yeah, this is the optimal solution that we can have. So I hope guys you have liked my if you have liked my video, then please do like and subscribe like my video and subscribe my channel. And if you feel there is some drawback or I have missed out something, please do mention it in the comment section. Thank you everyone.